Yeah, the scar.
So, okay. Number 14. X times the absolute value of y. X is -3 and y is -5. And I'm really glad that this problem came up because there was a very common mistake on the quiz where people added these numbers or subtracted these numbers instead of multiplying them. So when the letters are right next to each other like this is -5. This is not -5. So absolute value of -5 is 5. So you go -3 times 5 like this. And that is -15. That happened a lot of times on the quiz, like a bunch of times. Okay, and then number 16. Oh, it's square root of 16. How fun is that? Okay, what number times itself is 16? 4 and 4. Square root of 16 is 4. Wow, that was lengthy. Not really. Okay, now we are going to use a resource page today. So if you could find this guy. Dang, this part you might want to put in later. You might want to wait for not write this all down. Scooch this over to the side though. So find this guy. It's got candy at the beginning and then but we need to start with 43, which is going to go in your notebook. Okay. We need to read number 43 together from the book. Here we go. Number 43, the soda machine. The soda machine at your school, which is really sad because they won't let us have a soda machine anymore, but we used to have one. The soda machine at your school offers several types of soda. There are 2 buttons for your favorite drink, Blast, while the other drinks, Slurp, Lemon Twister, and Diet Slurp, each have 1 button. Which do you think would be your favorite? I'm going to go with Diet Slurp for me. That's not enjoying our context of soda at all. Okay, so there's 2 Blast buttons, 1 Slurp button, 1 Lemon Twister button, and 1 Diet Slurp button. Okay, A, describe the input and output of this soda machine. So what would the input be? And pretend they're free. Pretend it's free. What? You guys are thinking mathematically speaking, not sodally speaking. Okay. What do you do to the machine to pick your, yes, push the button. Push the button is what I was looking for. The input is the button you push. And what would the output be? Yes. The soda that came out. Perfect. Okay. You guys are using awesome math brains. Okay, so the input in this very silly situation would be which button was pushed, and the output would be which soda came out. Okay. B. While buying a soda, Miss Whitney pushed the button for lemon twister and got a can of lemon twister. Later, she went back to the same machine, again pushing the lemon twister button, but this time she got a can of Blast. Is the machine functioning consistently? No. Okay, so what we're going to do is we're going to draw a little picture. We're going to draw a little picture of the lemon twister button. So pretend that's the button on the machine. And the first time she pressed it, she got a lemon twister. And the second time she pressed it, she got a Blast. Okay. C. When Brandy pushed the top button for Blast, she received a can of Blast. Her friend Miguel decided to be different and pushed the second button for Blast. He too received a can of Blast. Each of them asked 5 friends to push 2 Blast buttons and they all got the same result, a can of Blast. Is the machine functioning consistently? Yes. Okay, now in D, I'm going to try to trick you. Those two are not tricky. D is tricky. Keep your eyes, your math brain out for D. When Lutfi, anybody know how to pronounce that? I'm going to go with Lutfi. Any other ideas? Okay. Pushed a button for Slurp. He received a can of lemon twister. Later, Taisha also pushed a Slurp button and received a can of lemon twister. Still later, Taisha noticed that everyone else who pushed the Slurp button received a lemon twister. Is the machine functioning consistently? And that's the keyword, consistently. Yes, it is. What do you think happened? They probably loaded it incorrectly. Like the dude who loaded the machine up probably put the wrong thing in the wrong spot. So it's not really the machine's fault. It's just some kind of like operator error. Okay, so when you finish writing this, then scooch your notebook over to the side and scooch the packet back. We're not done with the notebook, so don't put it away. Just scooch it over. Okay. 44. In a relationship like the soda machine, we want the output to be consistent and predictable. When it is, we say that the machine is functioning properly. Examine each of the tables below that show different inputs and their outputs. Decide if the relationship could be describing a machine that is functioning properly. Explain your reasoning. Okay, and notice they're going to take it from soda, candy, whatever, and then it's going to end up being math. So there's the transition from the context to the math right here. So in the first one, they pushed button 1 and got a Stix, which I believe is Twix. Then they pushed button 1 and got a Stix. Then they pushed button 2 and got an M&Ms. I think CPM is trying not to get sued. And I think they push button 4 and get an M&Ms. And then they push the button 2 and get duds. Is that what you should expect from button 2? No. Okay. So how we kind of show our work on these is we circle the two that show that it's not functioning consistently. And we say, button 2 is not functioning consistently. Okay. Next one. Pushed a 7, got a 6. Pushed a -2, got a -3. 0 got a 4. 4 got a 2. 9 got a 10. -3 got a 6. -3 got a -3. 6 got a 0. Okay, this might look a lot more confusing, but what you're looking for is in the input section, do any of the numbers repeat? That's the problem. You see these two repeated. Is there any repeat inputs? Okay, so we're going to turn this into math now. Yes, it is a function. No repeating inputs. Okay, now this is where we check for your understanding. Take a look at table 3. Can you tell where the problem is in table 3? Yes. Yes. Okay, so right here and right here. This time the two outputted a 9 and the two output a -8. And what we say for our explanation is no, not a function. 2, it's not -2. 2 has two different outputs. Okay, next. A relationship between inputs and outputs is called a function if the inputs and outputs behave like a soda machine that is functioning properly. Discuss with your team. We're going to be the whole group, the whole class is going to be our team. What it means for a relationship between inputs and outputs to be a function. So it's basically saying, describe this in words. No inputs, which are x's, have two different outputs that are y's. So no x's have two different y's. Okay, now I'm going to teach you, it's kind of a trick. It's not really a trick, it's a technique, but it's kind of a trick to tell whether or not something's a function on a graph. Can you tell me what were the two circled coordinates in table 3? Okay, 2, 9. I'm just gonna loosely sketch them. So 2, 9 would be like here, and 2, -11 would be right here. 8? Where did I get 11 from? Who knows? Okay, does that make sense to you guys, like where those coordinates would be located? Okay, this is very important that you see they're located vertically on top of each other. So what you can do when you have a graph is examine it to see if there's any coordinates or any part of the graph that there's two right on top of each other, and then it will not be a function. We call it the vertical line test. Okay, what you do is you come to your graph and you draw vertical lines. On this first one, that's just going to be on the points that are graphed. And what you're doing is you're trying to see if any of your vertical lines touch two coordinates. Because if it does, then it's not a function. Like that was not a function. Did any of my vertical lines touch any two coordinates? No. So it passes the vertical line test. So we say yes, a function. I don't know why there's not a space there. That's not supposed to be one word. And we say passes vertical line test. That means that there's no coordinate directly above another coordinate. So there's no input that has two different outputs. Okay, take a look at the snail shell spirally deal. Do you see any parts of the graph that are located directly above any other parts of the graph? Yeah, a lot of them. Let's just put one vertical line right here. If it's going to fail, you only need to draw one example of failure. So right here, and right here. There's 3 actually in this spot. And we say, no, not a function. Fails. Vertical line test. Do you guys see the difference between passing and failing? Not math class, vertical line test. Okay, scooching down. What about this table? I'm trying to trick you with this table, by the way. Is this table a function? Yes, it is. These two, you're like, oh, but they're both negative eights. However, the output is consistent. And the other ones don't repeat. I just wrote a note about negative eight seemed to be the problem child there. Okay, last one. So la di da, di da. Did I ever touch two times? No. It passed. All righty, now scooch back to your notebook. Well, we're done with that. Okay, so for 45, we'll do 45 and then I'll move the notes down. So I actually have for you no, I don't. Okay, sorry. Thought I had a thing, but I don't have a thing. Okay, so 45. Question is, if I have a vertical line graphed, does it pass the vertical line test? No, definitely not. How many times would my vertical line hit the vertical line? Infinite times. Okay, so what we're gonna do is we're gonna just try to draw. I'm gonna get a different color because I'm just that way. And I'm gonna try to draw the vertical line test over top, and it would hit everywhere. Vertical line is really the only line that does not pass the vertical line test. All other lines do. This is the first time you're figuring that out. . Okay, let's do the function definition. A function is an equation, table, or graph where there are no inputs, and I'm going to make sure we say that that's x's, that have two different outputs, which are the y's. Okay. This is the last thing to set up, the last thing we're doing today right here. And your graph does not need to be exactly like mine. Just make it some kind of sideways V. Okay, so fun fact, you guys have a quiz on the block day, Thursday next week. There's 3 questions, 3 topics. The first question is solving an equation. So like 2x plus 5 equals negative 6x plus 9. Undo, solve for x. And then you have to show your check and plug it back in. You guys know what I mean by that? Take your number and the answer, plug it back into the original problem, make sure the 2 sides equal each other. Okay, that's the first problem. I think. I actually don't know the order. Can't remember. But that's one of the problems. It's just regular solving an equation. The second one is a function machine. Same deal. Take the input, plug it in for x, get an answer. The third one is one of these. It's a table or a graph. And it said, the whole reason I'm bringing this up is because the third question gives you a table or a graph, and it says, is this relationship a function, why or why not? Okay, so you need to get full credit, you need to explain. And so we're going to do the explain, make sure that we have exactly what we need for full credit. So if you're given a table, what you do is you analyze the x's and scan your peepers on it and see if there's any repeating x's. And then you say, do they go to different y's? If they do, then you circle them. And you would say, no, not a function. Negative 6 has 2 different outputs. So that would be identifying it in the table by circling, making a decision, yes or no, and then explaining by saying negative 6 has 2 different outputs. Does that make sense so far? Okay, so that's what you do if you have a table. If you have a graph, you're going to draw lines on it for the vertical line test. You can see this one's going to fail just pick a spot where it will fail. And you'll say, no, not a function. Fails vertical line test. And that will be your explanation for that. So no, so you draw in your evidence on the graph, not a function, fails vertical line test. Okay, what if it passes the vertical line test? I just draw a bunch of vertical lines and then say, yes, passes vertical line test. But I put like a bunch on there to show that I tried it in a bunch of spots. Does the explanations and the work make sense? Okay, so last thing, look at the stamp sheet side of your packet. We're just about done. Tonight's homework is 47 through 50 in CPM. But I want you to notice Monday night's homework is the chapter 1 quiz 2 review. You already know how to do all of it. So if you want to start getting prepared for your quiz, you could do it early. You don't have to. I'm just pointing that out. The homework though is 47 to 50 in the CPM, which you can work on for the next 15 minutes-ish or so. Also, do you guys see this bookcase over here? The bottom row has Math 1 books, so you can go grab those. There's enough for 2 per table if you want to do work on any of your problems, or you can get the ebook on your Chromebook. I don't care.